just the outline of this and Monday session. So what we are going to do is, you already I think got the backend fundamental sessions done.
Yes.
So all the basic things which we need while development. So what we are trying to focus is all those things that are specific to Go, not or what are different from other languages in Go, and why you should or why do we use Go, all that things. So in this session, we will try to cover things starting from what are functions, like what are different things which we see in Go in functions. Then similarly methods, interfaces, and then moving on, how do we do error handling in Go. Then if you I've heard about what are differ functions and stuff in Go routine and so on. And the second session is kind of based on writing actual REST APIs in Go and unit testing and integration testing. How do we do that in Go? So if at any time you feel you have any doubt or stuff, of course you can raise your hand and we can discuss that. And in this sessions, what we have done is we have attached snippets of code. When we share this PPT, you can just go and view those snippets. They are all on Go Playground, so it's easy for you to. So just before starting, does like anyone know like what Go is, or why do you think, if you have ever used or seen lectures, like why do we normally use Go? What advantages it might.
It is based on concurrency.
Okay, yeah,
It is fast
compared to what?
compared to languages like Python and JS.
Okay. And then you might also have gotten options to select like Go. So like what did you consider while selecting like
Base language was C++, so easy to
okay.
transition.
Yeah, that is true. So just a quick intro to Go. So basically, you might have heard Go is a statically and compiled language. So what do you mean by statically typed? So basically, at compile time, Go knows like what are the types of the variables it has been declared, unlike Python or stuff. So that beforehand we know if there are any errors as such. And one of the main things, as he said, that concurrency. So due to which, and if you will of course cover those topics, but in Go's case, concurrency is mostly not OS managed. Go manages all its thread itself, first of all, so they become lightweight. So that is one of the main advantages, because of which we also use this in microservices. So if this is quietly, Go is quite famous for microservices to use there because it's fast, and when it makes deployment also easier, because if you see when we build a Go project, it basically gives us a binary which we can run anywhere we want. So that is one of the advantages. So sorry. Uh, we'll start with the first topic then. Anything you'd like to, any doubts till here? Yeah. And just let us know if you feel the pace is going fast or slow. Yeah. So we'll start with some basic things. So functions. So I think everybody here knows function. We'll just start off with what do you think? Why do we have function in any language? Let's say. So we try to build functions to first of all make the code readable. We try to assign a specific logic to a function so that our code is semantic also, readable also. And one of the main concepts is that we won't have to repeat the code. So if we declare any functions, we can just reuse it wherever we want. So all those things are common. So just a basic declaration. So we have the func keyword, which we use to declare a function, and the actual function name, and then a list of parameters. Not mandatory, can be empty, and then the return type, or it can be void. Doesn't need to return. Some of the things just specific in Go for functions is you can assign function to a variable. You can pass a function as an argument to another function, and similarly, you can also return a function from inside a function. Yeah. And so there are quite a few types of functions. You can explore this, but I'll mention one of them. So anonymous functions. So if you have ever worked in Python also, we have kind of inline functions.
Yes.
So this is a similar thing where we don't want to declare a global function or function name, all those stuff. These are used for some short-lived logic that, let's say, it's a basic 1 or 2 lines code which is needed for that particular piece of code only or that particular method only. So we can just declare an inline function. Then an inline function only has a function keyword, then parenthesis, and of course we can similarly pass any arguments to this if you want, and then the actual piece of code. Now once this executes, it is removed from the stack. So if you know function execution works in stacks. So whenever a function is called, we post that function onto a stack, and so once this block of code is executed, this function is vanished from memory. We don't see this, and we can't call it again then. So main use of anonymous function comes in short-lived logic. As I said, if there's a basic logic that does not require repetition over anywhere, so we can use this inline functions. So easy to use and understand too. Then there's a concept called closures. We'll see this ahead. Then callbacks. Callbacks, as you know, in all languages, we have, if I'm calling some functions and I want that function to call me back or some any other function, so we can use this inline functions. So basically, then Go routines. You'll see how we use this functions in Go routines. So just a overview. So Go routines syntax is similar to this. So what we do, we just add a Go keyword before this, and then we spawn the function, and then it can run in background basically. Uh, and then moving ahead, we have methods. So methods and functions are, if you look at it, kind of same. A same block of code, a piece of code, common logic we want to execute, but a difference over here is a method has a receiver type. Now, what I mean by receiver type is a type, basically, if you know about structs, right? So a struct, let's say a struct which has multiple fields, and you want your code, when you create an object of, let's say, user, you want to call specific methods on that object. So for that purposes, we can create methods on that type. So as you see behind me, we have a user struct and then a redact user function. And then this function, if you see the syntax, we have a func keyword, and then between the function name and the func keyword, we have declared the receiver. So this is called as the receiver. So yeah, we mentioned the type. So basically, the user type is implementing this function. So if I create a user object, I can call this function using that user object, let's say u. So I can just declare an object and then u dot redact user. So that is how we can call methods onto an object. And then it's not just structs. We can also declare methods on non-struct types. And by non-struct types, I mean, if you see over here, we have declared a type for a float. So basically, a float is a generic type in Go, a standard type. So we have declared, basically created a new type for float. So kind of an alias. So float 64, let's say int. We have just created a new aliasing for that int type. And now what I can do is I can write my own methods for that type. And if I now try to create a new variable, I'll use my user defined type, my float. And now what I can do is, since I have created a method for my receiver, my float type, right? So what I can simply do is I can call this absolute method on my user defined type. So does that make sense to you? Basically, you can use this whenever you want to create your own types and some user defined methods on your type. So whenever you want to use this, you can create a new variable for your own user defined type and then call this methods. And the one other important thing about this is you can only declare a method with a receiver. So basically, whenever I create this method, the apps method is created and the receiver is my float. Now this type is declared in the same package. Let's say if you don't know packages, basically let's say a directory. So the type and the method should exist in the same directory. If it's the type is in another directory and the method is in another, it doesn't work that way. So they both have to exist in the same package or same directory. And let's so yeah. And then as we see, we mentioned the receiver over here. So receiver is nothing but a type or an object. Like so, there are two ways we can do this. Either the receiver can be of a type pointer or a value based. So the main difference over here is if you might know like what are pointers and values, right? So whenever we define a pointer receiver, when we call a particular method, let's say I have declared a pointer receiver over here, and when we call this redact user for this u object, now this object has actual access to the internal fields, the internal address of this object. So whenever I make any changes for this type now inside these functions, it reflects in the original object. But on the contrary, for value based, so yeah, we have a example over here. So for value based, we so this is passed by value, a normal function, and this is a method which has a receiver type of user. Now, what do you think will happen in this case? So let's say I have this user object and I pass this to this function, a normal user object, and I change the encrypted password to empty. It was this before, and I returned it, and I am trying to print this user object. You get the question, right? We declared a user object which has name, email, and encrypted password, three fields. And then we have this function, a normal function which accepts a user type. And then internally, what we are trying to do is we are trying to change the password and then return a void return basically. And then we try to print this u object. So what will this print? What will be the value of name, email, and encrypted password?
Name and email.
Yeah.
So redact, when we are calling the redact user, we are asking pointer. But in the function, it's not the parameter is not pointer. So how is it possible?
We actually won't pass over here. This is a typo, but we won't pass the actual. We will just pass it by value, not the pointer to the function. So pointer to the method actually user object. Consider it as a normal object, u object, without the pointer. So anyway, what will it print if I try to use the first function and print the object of user?
It will print whole object like we are passing by value, so it will not get manipulated.
So the same as we have declared it above. And in the second case where we have declared a method using the user type as a receiver. In this case, what do you think will happen?
Same.
Same.
I think in the first case, value won't get. Second case,
Uh, why do you feel like the second case
because we are calling the u dot like u is the object, and we are calling the method to the object. So the second one might change the object. The first we are calling directly method.
the first one of course won't change, but the second one also won't change it because if you see the receiver, it doesn't have a pointer. So the receiver is a normal receiver, a value receiver. So what happens is a value receiver receives a copy of the struct. So it is making these changes in the copy it received, not the original one. So let's say another example. Now you see here, so we have the pointer receiver. So what happens is when we now call you that redact user, what it does is instead of passing a copy, it passes the underlying struct itself. Now when we try to change this, it will actually reflect in the original struct. So these are some of the things we might need to consider when we actually develop our code, if we actually need to do this or not. So if you think about it, some situations where we need to use pointer receivers. Let's say we have a struct which has 20 fields. Now, instead of each time when I call any method, so if I use a value receiver, each time the struct will be duplicated, copied whenever I call a method. So instead, if I use a pointer receiver now, so this is one of the case. So if I use a pointer receiver, it will just send the underlying array. So we'll save some space over there. This is one of the reason. And of course, and another reason is if you want the method to update some of the fields of the original struct, original object, you can use the pointer receiver. But it's not mandatory. If your, let's say the user struct, this is quite small. It doesn't matter if we use a pointer or a value receiver. So we can use a value receiver over here. The copy won't be that large. But if your struct is quite large, contains a lot of variables, and it calls a lot of methods, then it might be wise to use a pointer receiver in that case. So any doubts still? Yeah. So moving on, we have interfaces. Now, interfaces is one of the important topics. So if you have any confusion or doubt, please let us know. So you might have also heard interfaces in different languages, right? So what is your definition for interfaces? What do you think interfaces are?
Interfaces are like abstract of the classes in C.
Like you define the
Blueprint.
Actually, the logic is not written in the interface,
Hmm.
but it is written in methods, and methods belongs to interface.
Yeah. So the same definition, underlying definition still is the same. Like you said, a blueprint or I mean basically a set of methods which tells us like what are the actions, but not how it is to be done. So similarly, Go also has interfaces, and the same way it helps us to define method signatures or actions what this interface needs to perform. So, now I'll show this with example. And if you have also seen that, let's say if you have done Java or C++, we either implement or inherit when we implement those interface methods. But in Go, it is designed in such a way that we don't need to inherit or implement or use those keywords or use those, what we can say, ways to implement the interface. So it's quite easy actually. If you see, let's say I have an interface. Uh, so we have a interface and we have two methods for that interface. Now what I can simply do is we can have a struct, and if that struct implements those exact method signatures, we can say that that struct or that type implements the said interface. So see an example. We have a struct T and it has a single field S. And if you see the above interface as a single method defined and a single method M which does not take any argument, does not return anything. So if our struct T defines this method, we can say that our struct T implements this interface. So as simple as that, no need to use any keywords such as inherit or all those things. Inheritance composition is not. So this makes it simple to use. And if you see, there is also a concept of empty interface in Go. So an empty interface is what you can say just a top level declaration. So I just declare a type, let's say type I interface, and no methods in it. So if you now think logically, what we said is that whichever type or whichever struct implements the methods of an interface, we can say that it satisfies that interface. But if we have an empty interface, then logically all the types implement that interface, correct? So due to this, an empty inter we can assign any, let's say any variable, let it be concrete type, int, float and stuff. We can assign that to an empty interface because logically speaking, they implement that empty interface because it has zero methods. Similarly, the concrete types, int, float, bool, they also don't have any inbuilt methods. So they are implementing nothing. Does that make sense to you? Because if if you think about it, an interface has some methods. If anyone is implementing those methods, we say that it is following that interface. But if as it has zero methods, then we can say everyone is basically implementing that interface. So this is quite useful actually. We'll see. So see, we have an interface over here, and we haven't declared any methods over here, and we call this describe function over here. So in that case, what do you think will happen if I just declare an empty interface? I'm calling the describe method, which takes interface as an input and just basically prints it. So basically percent %v is for value and percent %t is for type, the type of that variable. So any idea or any guess you think what will be the output in this case? No, in the first case, when we call this one, zero.
Empty string.
But there are two, right? I the value and also the type.
Any, I guess, null or interface. Interface is
So let's not define, but think of interface having two values. One is the type, which is it holding, and the actual value of the type. So there are two things. And an interface is considered as nil when both of these values are nil. But the type is also nil and the value is also nil. So in this case, in the first case, if you see, we just have defined the interface. We haven't assigned any type or any value, nothing to that interface. So in this case, what happens is the value is also nil and the type is also nil. So until we assign anything to that interface, a user defined type, a user defined struct or anything, the interface is considered, an empty interface is considered as nil. So in the second case, we have a variable. So basically we assign a number to the interface. Now in this case, what happens is, as I told you, that an empty interface is implemented by each of the types. Let it be int, string, or something. So when we do I is equals to 42, it is an integer. So we can store this in the interface because an integer implicitly defines an empty interface. So when I call the describe method for the second time, now in this case, what do you think it will print?
into an end.
Correct. The value it stored is the number 42 and the type, underlying type of that value is int. And then similarly, if we go to the third example, we are now storing a string. So when we try to print the value, of course, it will print hello. So this can be used in places, where we want to, we are not sure, we are not sure of what input we might receive, or we want to create some generic function which can receive any type, which can receive an integer or a string, a boolean, anything. We don't know. So we can use this as a receiver in a function and such functions. And then internally, we'll show you further. Internally, we can use switch cases to determine like what type it is, and now depending on that, what we want to do. So this is one of the use cases. And one other thing that like let me show you an example. So how interfaces are kind of useful in actual coding too. So let's take an example of a payment gateway. So if you see, we have a create payment session and a complete payment session. Two methods. Let's consider this. So the create payment session is used whenever, let's say, I am placing an order and the order is going to the gateway, let's say Google Pay. And then we consider this as a session, right? So this ends, if you see, it ends after some time. Let's say you're on Swiggy, it gives you a timer that, let's say, 30 seconds or 1 minute, and the session will end. Then you will have to reorder basically. So we have a create payment session, and when the actual order is done, the payment is completed, the money is been deducted from your account, and then we call the complete payment session. So for a payment service, these are the two methods you need to implement. So our interface defines that if you want to implement a payment service, you need to have these two methods. But it doesn't care how you are implementing this. So what happens is, now if you see, this method is used in multiple places. So now let's say we are using Razorpay for payments, but now I want to change Stripe or PayPal. So if we use methods, in that case, it becomes a dependency that if I want to change that method, I have to go and change it at multiple places. But let's say if we have defined an interface and all our internal functions, wherever we want to call this create payment session. So we have created this interface. We have a Razorpay object, let's say, which defines this interface. And then internally, what we can do is we basically call this Razorpay payment service, and there's this create payment session. Now, let's say if there are any changes in this create payment session, it doesn't matter to us. Or I want to introduce a new payment method. Razorpay is still there. I want to introduce Stripe. So what we can simply do is we can create a struct for Stripe. It also implements this same method. And if ever I want to change this, we can just simply change the service from here. No need to deal with anything of the implementation over there. So this is also useful when we use third-party libraries, if you think of it. They make any changes to their functions, it doesn't matter. If they are internally changing the libraries or stuff, they implement basically defined interface methods that the signature will still remain the same. You don't need to care about of what's there inside. And this is one of the use cases. And other will also see how this is useful in testing when we get through that topic. So any doubts over here for interfaces? If you have anything, that no question is silly over here, so you can ask anything. Because it might take some time when you start also using interfaces. But this is one of the important things. Whenever you start coding in Golang, you will definitely at each step will need this and use this. So if nothing, I'll go ahead. So then coming on to another topic for interfaces is type assertion. Now, as I said earlier, that we can define a function which has an interface as an argument, and we can pass any type to it. Let it be an integer, boolean, or string, anything. So I have passed this to the interface, but now we need to identify what the underlying type is. So that thing is known as type assertion. So what we can do is, if you see the syntax over here, here I is an interface and I dot t. So what does it? This does is it returns the underlying type the interface is storing. But what happens is, in a first case, when we haven't assigned any value, any type to the interface is nil. So if we directly use this, and if the interface is nil, this goes into panic. Let's say an error of a kind that it errors out because it doesn't have anything. A nil doesn't have a type, so it errors out. So a better way to look at it is using this method, like this kind of approach. So what it does is whenever we try to check the underlying type of an interface, it generally returns two things. The actual type, and if the type is present, it returns true, the second value. But if it is nil, it returns false. So in this case, it won't error out. So we can check if this interface is nil or not by this method. So Yeah.
So can you explain previous one, the okay one?
This one. So what happens is, let's say we have assigned I is equals to 42. Now when I do I dot t, so what will happen is in the second case, the t will contain the type, the underlying type, which is int, and the OK will contain a boolean, a true or false, so which it defines that this interface has a type and a value. It's not nil. But if in case it is nil, this then returns false. So what we can do is we can now check, right? So if this is nil, we'll know from the second variable. But in the first case, what will happen if the interface was nil? It will error out because it doesn't find a type. So the second one is a good approach if you are trying this out in actual code. This is generally like you're confident, hey, isko type, so we can directly use this. But this is also a safer way to do the same thing.
So the second one returns Boolean value, while the first one returns actual type, or it also returns.
This is actually same, but it is to you if you want to catch that return value or a second return value. So it's recommended that you do because then it won't error out.
But it will return true, and we won't get actual type. Or it
No,
will-
if you see there are two variables for it. So what will contain, if there's any type, then it will contain the type or not. If nothing, then nil. So we have an interface. We have assigned a string to it. So in this example, what do you think the first uh, println will output? The output of the first fmt.println.
True and
The example is visible, right?
yes.
Sorry.
True and the next line.
Two for the first one,
Yes.
and then for the second one,
True.
True and true. Yes.
and what about the third?
Same.
false.
If you see in the third, what you're trying to is dot int, but x originally is a string.
Yes.
So when we try to do this, like we are trying to assert that this is an integer, but as I said, it is not. So in that case, this will return false, that it's not an integer. So if I didn't do it this way, so it will error out. If you see the last case, let's try to see over here. See, these are the first three outputs, but the last one where we didn't use this method. So what happens is we are trying to assert that we are trying to say it that this is an int. And it says no, it's not. So this will error out. So it's better to handle it using these cases. So if not, it will just simply return false. And so if you had went through the Go tour, you would have heard of zero values. So zero values are nothing but default values for each type. So when I said that x dot int, but it internally was a string, right? So it returned false. And since we tried to say it was int, it just returned a zero value for that int. Or if I had returned x dot bool, so what it would have done is it would have returned the zero value for bool, which is false.
And so for string, it will return empty string.
The n you're talking about?
Yes.
So in case of h dot int, what happens is since it was a string, right? But we tried to assert it to int, so it will return the zero value for int, and then second is false because it's internally not right.
If we declared interface as integer,
Hmm.
and if we check if it is string, so it will return empty
Empty,
string.
Good. Makes sense to you? So one of the last topics in the interface, which is so in the earlier piece of code over here, what we did is we actually asserted the type. We said that if it's a string or int, right?
Mhm.
We were trying to get out the actual concrete type. But in cases, as I mentioned, when there are situations that we can receive any value. We don't know if it's a string, integer, or stuff. So in that case, we can use switch cases. So what happens is so this is the actual syntax. So what we do is we declare the switch case similar to C, then the first argument, or on which parameter we want to write the cases, right? So over here, what we do is we try to extract the underlying type in this v variable. So when we write I dot type, what it does is it just returns the type stored in that interface. So if it's int, it will return int. If it's bool, it will return bool. And now since v stores the type the interface is storing, we can now write switch cases. So let's say switch case can be case int. So if the value of v is int, it will go in that case, and we then case second can be string, bool, and default if none of the cases match. So this is one of the useful ways when you want to declare some functions but you want to pass multiple types to it. So you can just accept an interface and then internally write a switch case and then decide uh, on what type you want to perform what operations. Make sense, Julia? So now we'll start off with the error handling part. So any questions in functions, methods or interface? कुछ भी सर छोटा सा बाद में भी पूछ सकते हैं, कुछ नहीं है, सब कुछ रहेगा तो लिख के रख लो फिर.
Okay, share this company. So, how's the training going on till date? Yeah. So, Prasad has covered all the basic blocks like interfaces and methods. Now we'll move forward. How to structure our project? What are the necessary things our project requires? So, you all know what are means the content we are in this session. We'll cover all error handlings, defer statements, panic recovery, context, and go modules. So this will cover all the entire the flow of the program, how to construct your Go program, right? So can you someone tell me what do you mean by errors? What do you understand by errors?
Failure.
Failures, okay.
Bugs.
Bugs,
Case
So-
cases where we did not handle it properly.
okay. And what's the difference between error and exception?
Exception is something which comes at runtime. Error basically we know
At
before
compile.
Okay.
at compile time, we can say.
Yes, that's right. Error is nothing but an abnormal behavior of our program. So if there is an error in our program, we should handle it ourselves and not allow the programs, not let our program go out of our control. So we should handle it gracefully. So in Golang, error is nothing but like we have the various data types like integer, float, strings. The similar way we have a one type errors. So these errors can be assigned to any variable. This can be passed to functions and also can be written from functions. So it is very essential in Golang to handle the error properly. So in Golang, what do we follow is that we handle the failures by returning an error and not raising an exceptions. So in other languages like Java or Python, you have seen that you are raising an exceptions and you are using a try catch block. You are catching that exceptions, and in that way we are handling an errors. But what happens in Golang that we promote that. Just a second. In Golang, we handle errors by returning an error value. So, basic structure to declare an error is suppose we take a basic example. So, I have a main function here. You have read about the basic Golang, right? How to declare functions, how to declare variables, how to return from a function, right? So, I have written one function here, function name divide, which accepts a two parameter a and b of type int, and which also returns a two parameters. First is integer and second one is error. So what operation I want to perform in this function is I want to divide a number a by b. But before dividing that number a by b, I am checking that if whether the number b is 0 or not. That is the basic requirement I want to check. So I have added a basic check here. If b equal to 0, I want to return that there is an error. So as my function returns two type of error, I'll return the base 0 value for the first return type, that is integer. So I'll return 0 and I'll return one error, can't divide percent d by 0. So this is a way to declare an error, means to create an error. We will see in this next phases how to declare an error, how to construct an error. So I'll return what I want to return, a divided. If not, I'll return a divided b, and my error value is nil. So this is how we return an error. So the responsibility of Scholar is whenever the function is returning an error, it should catch that error. So in the main function, I am declaring. I have two variables. This is the blank identifier. I don't want what values that function returns. So if I don't want that value, and if I declare a variable for that, the Golang throws an syntactical error that this variable is unused. So I don't want that variable, so I have declared it as a blank import, and the second value is error. So the idiomatic way in Golang is that for the error handling, we check that whether the error is returning any value. So if an value of error is non-nil, we consider that the function has not returned any error. Or if the value of error is nil, we consider not non-nil, we consider that the function has written an error. So as we have passed the 0 here, the function will return that can't divided by 0. So that's how we have just printed that error has occurred, and this is the format specifier for error. So let's check. Yeah. So what error is? So error is an interface in and Go. So error is just a simple interface in and Go, and this interface has only one method, that is error, which returns the string. This error method is used to describe an error. So any zero value for this error is nil. So there are various ways that we can construct an errors in Golang. The first, you have learned about the built-in packages in Golang, right? So what are the various built-in packages? At least how to import packages in Golang. Okay, so there is a basic package FMT that we use for a printing statement like com.println. Similar to that, uh, we also have errors package in Golang, which is included in a standard library, which provides a new function new. Whatever the values we pass to that new function, it will return an error with that value. This is a very simple function that we use to construct an error. But what if we want to provide a more detailed error? Like this only provides a string, user defined string. What we want to if we want to propagate the error which I have got from the previous function. So for that, firm.errorf comes to rescue. So we can format error with the help of firm.errorf function. So in this function, we can use the format specifier like this. I have used a percentage here and pass the value to that function. So this will print the error with more described message. So let's check one example for this. Yeah. So I have one function here, function name function1, which returns an error. So I have simply written one error, constructed one error, and returned from that function. This is a very simple basic function. So I have constructed one error with the help of errors package, right? Errors.new, something went wrong. And in the main function, I am just calling this function error1. I am assigning that error value to a variable error, and I am checking if that variable is nil. If not, print that error. So what I have done here is form.println error.error. If I do error.error, this will describe that string which I have passed in errors.new function. So I'll just simply run this. Okay, so it has done something went wrong. That's our actual error. So far, so good. Does anyone have any doubt? Yeah. Then the second one is using the firm.errorf. Come in the previous code. Yeah. So what the function 2 does, it will construct an error with additional information. So I have used the format specifier here. We are using a format specifier %d for any integer, %s for if it's a string. So I'm constructing an error here and returning from a function 2, that is error number, and this is the format specifier. This will hold the value 1 and the cause is unknown. So when I run this, it will simply print error number 1, cause unknown. Sorry. So it just print error number one and cause this unknown. So these are the various types in which you can construct an error and return from a function. Is this clear to all?
The errors.new you see highlighted over there, it actually points to the actual error package in Go. So you can actually see the internal implementations if you want.
You can always see any implementation of a Go standard library, as Go is an open source language. You can see how this new is implemented internally, how this error works internally. You can check this anytime. So there are various good practices while handling an error in Go. You should always check and return errors. So there are good practices in Golang. The first one is always check return errors. Before that, when we are declaring a function, we are returning, there is some responsibility of a function, right? But with the responsibility, we should always return an error from a function. This is considered as a good practice. And while calling that function, caller should always catch that error. If we are not catching that error, we are inviting ourselves some trouble. So, and in the program flow, if there are error is occurring at any place, we should return from that early return from that place itself. So, and while declaring a function, there is a syntax of declaring function. Like if a function is returning multiple values, like function is returning three values, value A, value B, and value C. So return value should always be the last one. We should always keep that error value as the last one. We should always define and use expected errors. So if their error is user not found, we are using that error in uh, multiple levels in our code. So we can declare that error as a constant somewhere, and we can use that errors at a multiple times to return or to check if this is the specific errors. And if we got not nil error, means if a program, suppose let's say we will take the previous example which returns the three values, and if a program returns a non-nil error, so we should always return the zero value of other parameters. Like we have seen the divide example, I have returned zero. That was the zero value of a type integer. So that's a good practice. And most important thing is we should always write a good error message. This always help while debugging. Suppose our program is not expecting as we behave, or if you want to see the logs at 2 days later or 3 days later, we should always understand what happens from that log message. So error log message will be as good as our code. Yeah. So this was all about the error handling. So do anyone have any questions?
Don't you have any stack trace or like where the error occurs?
Yeah, so whenever the error occurs, we return immediately. We can have this error stack trace with the help of error wrapping. So there is also a concept, we can wrap the errors with the help of error wrap package by providing a format specifier %w. This will stack the errors in sequential manner. Yeah, you can read more about that. This was the basic thing I covered. If you want to explore more, you can always read the documentation, or on the internet, all is available. Yeah. Anyone? Everyone has understood?
We see two types of returning error with error new and error F.
Okay.
Why there are two types? Like in which scenarios? Can you explain that again? Which scenarios? Which one is preferred?
Yeah, but both are returning an underlying type of error only. But errors.new is providing very simple error, like something went wrong, or only the message I have given to the means the developer has given to the function, that only error. But this message does not include what was the actual error. Suppose an operating system has thrown some error, or a third party has thrown some error. This will be not included in that errors.new, because we cannot format error there. But with the help of format specifier, like using error.errorf, form.errorf, we can format that error too, along with our user defined error. That's the primary difference. Now, the second thing is defer. So in Golang, we have a defer keyword. This defer postpones the execution of the function until the surrounding functions returns. This is useful in recovery. If our program panics, this helps us for in recovery. So the basic syntax of the defer is we just have a normal Go keyword defer, and we can have a simple function call in front of that. So there is a order of execution of these defer statements. So whenever a function is called in a defer statement, it goes in a stack, and it maintains its orders. Whenever the function returns, this stack one by one functions are popped out and returned to the means evaluated. So this follows the last in first of the execution sequence if multiple defer calls. We'll just see one example for this. Yeah. So I have one main function here. I have declared one statement. I have just printed one statement in defer. In line number 10, I am declaring one for loop. It will be iterating 10 times, and for each iteration, it will be incrementing the value of I by 1. And for each iteration, it will print iteration and the value of I here. And at the line number 14, I am just printing the end of the function. So can someone guess what will this output?
First will be the iteration,
First will be
iteration count,
okay,
then end of the function, and then hello world.
right. So what when I declared at line number 8 defer statement, this goes into a stack. This means the statement is evaluated itself, but it is not written, so it goes in stack. At line number 10, for each iteration, this iteration will run for 10 times. This will print this iteration 1 to 10, 0 to 9, sorry, 1 to 10, and at the last it will print that end of the function. But here the function is returning naturally, right? So when the function is returning naturally or we are returning explicitly, it checks that do we have anything in a defer stack. So it found that we have a statement at line number 8 that hello world. So it pops out that statement from the pop and it prints that. So let's execute this program. Yeah, let's see. Iteration 0 to iteration 9, end of the function, and it pops the defer statement out of the stack.
Suppose we have written for loop in function.
Okay.
And we have written it like return nil or return zero like that. And then
Return for loop and nil.
means we have to return something na, from function. So we
Okay.
have written null, means nothing is written.
Hmm.
Iteration is done. At the end, there is that print statement. So after that function is run already, the iteration one.
Hmm.
So it will print first go to defer or end of the function word. मतलब
So
वो
I did
for
not
loop
got
जो
your
है
question.
उसको हमने एक फंक्शन में रख दिया
और
means
function में
हाँ, तो अब फंक्शन को अपन रिटर्न कर रहे हैं एक्सप्लिसिटली बता रहे कि अब रिटर्न
मतलब फंक्शन मेन के बाहर का एक फंक्शन है, उसमें फॉर लूप है।
हाँ,
एक मैं
और
स्टेटमेंट लिख रहा हूँ फर्स्ट डेफर में हेलो वर्ल्ड,
हाँ।
वो फंक्शन कॉल हो रहा है इंस्टेड ऑफ दिस फॉर लूप,
हाँ।
एंड देन ये हो रहा है, राइट?
हाँ।
सिमिलर वे में रिटर्न करेगा क्योंकि वो फंक्शन खुद रिटर्न कर रहा है ना, वहां पे कोई डेफर स्टेटमेंट नहीं। अगर वहां पे कुछ डेफर स्टेटमेंट होता तो वो फिर स्टैक में चला जाता, और फिर उस जब उसने रिटर्न किया तो वो डेफर स्टेटमेंट प्रिंट हो जाता, और फिर ये स्टैक में लास्ट इन फर्स्ट आउट। तो हम आगे देखते हैं
डेफर जिस फंक्शन में है वो फंक्शन जब रिटर्न करेगा किस भी वजह से, रिपीट एनी एरर, तुम खुद से रिटर्न कर रहे हो या पैनिक हो रहा है, तो जब भी वो फंक्शन का स्कोप से बाहर जा रहे हो उसमें कुछ डेफर था तो वो प्रिंट हो।
मतलब अगर हम वो उसको फंक्शन में डालेंगे और उसके अंदर एक डेफर करेंगे तो फिर वो डेफर स्टैक में जाएगा।
हाँ, वो
And
देखते हैं
जब
हम
तक
आगे,
होगा
तो मतलब वही कवर करने वाले हैं, तो फिर उसके बाद भी आपको डाउट रहेगा तो फिर पूछ लेना। So first, how is the deferred argument evaluated and what's the order of execution? So as we have talked that whenever a defer statement is whenever a defer statement is mentioned, this statement goes into a stack. So the deferred calls argument are evaluated immediately, even though the function call is not executed until the surrounding functions return. Suppose we are calculating any value. Suppose I have value of I. I'm incrementing that value, and it's in defer statement. This value is evaluated immediately, but it is not written but it is not executed, but it is evaluated immediately. So let's understand by one example. Yeah. So I have a simple function here, print num function, which has a responsibility just to accept one integer and print that integer in num. So in main function, what I have done is I have declared one variable I and assigned its value 1. I am calling a function print num in a defer statement. This is the first defer statement, right? Which prints I. So this goes into stack first. This is pushed into a stack. Now the second statement is normal print statement, first main element. So it will be get executed immediately. So first output will be first main statement, right? Now I'm incrementing the value of I. Now just observe that I is incrementing, right? But this statement is still not printed. But I is incrementing. Now I have a value of I as 2. But and now I have a second defer statement, the print num. So I'll pass 2 here, and this value go into stack. Second value goes into a stack. Now the third one is similar one, I into I, 2 into 2. This value will print 4. This again goes into a stack, third value. Now what happens? This main functions returns naturally. Now whenever function is returning, we see if we have any values of present for a defer statement in a stack. So we found that there are 3 values. So we'll at the stack will the first element, last element will pop first. So it will print this first 4, 2, and 4. Let's print this. Yeah, so it will print num4, num2, and num1. This is the order of execution and evaluation. So is it clear until it?
Yes,
Okay. So what are the cases when the defer statements are executed? There are multiple cases when the defer statement gets executed. The first one is the surrounding functions finishes its execution. Just we have seen the example that the main function has finished its execution and we have returned the defer. The second one is when the including function return statement is encountered. Whenever suppose this function was returning naturally, but even if you have written it explicitly, this defer statement is evaluated and returned. So we'll see one example for that. So link. Okay, so this is first case when the encounters return. So I have just defined one function encounter return. I have added one statement in a defer that open source one, open resource one. I have normal print statement, close resource one, and I'm returning it explicitly. Like if true means this condition will always be true. Return. I want to return from this function, but even after returning from this function, I have another one defer which prints that open resource two and a normal print close resource two, and I'm calling just simply calling this function in the main function. So can someone guess what will this output?
Close resource one and then open resource two.
Okay, right. So I will run this. It will first print close resource one. First it will evaluate like open resource one, but this will be put into a stack, and this will print normally close resource one, and this function is returning explicitly that we are returning. So it will check if there is there anything in the stack. It pops that stack and print that value. So this line number 23 and 25 will never be reached because the function is returning early. Even though it contains the defer statement, it is not reached. The second condition is false up. Yeah, false of means here we are in the above example we are returning explicitly. In the false of, the function returns itself naturally. So we have a normal statement, first defer statement, then again normal statement and defer statement. So whenever a function returns normally false of, it will print this defer statement out like close resource two and then close resource one sequential. It's last in first of it. Okay. The third most important one is when a function panics. So do someone understand what this panic means? Like when our program panics.
It is expecting something, but it does not get what it wants. It is not error.
Hmm.
Like sir told about interface. So it was expecting a value, like type of interface, but it is not getting the value.
Yeah, you can relate to something to like we talk about the exception link, right? It throws an exception. Panic means it throws an exception. Something unexpected happens and our program goes out of the control. Like suppose I have an integer of length 3 length 3 and I am accessing the fourth element of index. So our program goes out of our control. So Golang does not understand what to do in this case. So the program panics. So whenever the program panics, then also the defer statements are getting called. So there are multiple ways we can also panic our program explicitly using the panic keyword in Golang, and there are also multiple accessing the element out of the bound divided by zero or means accessing a nil map, inserting elements into a nil map. These are the various cases where our Golang program can panic. So it is very important that we should recover from this panic. We should not get our program get end abruptly. So for the time being, I'll just use a Golang keyword panic occurred. Right. I want to create an explicit panic. So this simple function, what it does is, as the similar function above, it prints normal resource one. It puts one statement in a stack, a defer. Again, it's print open resource two. This defer statement goes into a stack, and at this moment, our program panics. Right? Whenever the program panics, what it does it returns the defer statements. So it again says if I have something in a stack, this will return that values. So we'll see. It will also print the stack trace of why the panic has occurred. Yeah. So open resource one, open resource two, and this panic statements. And this was the panic occurred. That Golang has panicked here, and this is the stack trace of that panic. Yeah. So is everything clear until this?
We control which function, like if I'll say that he sir defer में 3 function चले गए, stack में 3 function चले गए, and so can I selectively call out each function, like मुझे stack में से बस थर्ड वाला function ही बाहर आने को like कौन होना चाहिए,
पैनिक हुआ तो जो स्टैक में सभी
सर तो सभी आ जाएंगे, but
हाँ।
मुझे अगर selectively एक ही चाहिए, मतलब टॉप ऑफ द स्टैक वाला ही बाहर चाहिए, वैसा कुछ हो सकता है, like बस थर्ड फंक्शन ही बाहर आना चाहिए, फर्स्ट दो वही रहो।
नहीं सर नहीं
सर बिकॉज द थिंग
वो
इज लाइक
इंटरनली हैंडल्ड है, क्योंकि वो जो फंक्शन स्टैक है वो हम एक्सप्लिसिटली हैंडल नहीं करते, वो दो रन टाइम खुद मैनेज कर। तो एक बार तुम लोग ने स्टैक पे फंक्शन कॉल डाल दिया, तो अब जब पैनिक हो, जैसे पैनिक का केस है, तो पैनिक के केस में क्या करता है, और जो भी सीक्वेंस है, लेट्स से ट्री समझ लो कि एक फंक्शन ने ये कॉल किया, ये कॉल किया, ये कॉल, जैसे पैनिक हुआ तो वो जब तक पूरा प्रोग्राम एंड नहीं हो रहा था, जैसे स्टार्ट हुआ था उधर तक जाएगा वो रिवर्स। वो रिवर्स जाते टाइम क्या देखेगा कि स्टैक में क्या क्या था, तो उसमें जितना भी है वो कंपल्सरीली एग्जीक्यूट करते ही जाएगा। अब तुम्हें बीच में, फॉर एग्जांपल अगर बीच में तुम्हें रोकना है उसको, तो अभी एक्चुअली जो नेक्स्ट टॉपिक है तो तुम देख सकते हो उसमें रिकवर में, दिस इज इन केस ऑफ पैनिक। नॉर्मल रिटर्न के केस में जितने भी डेफर होंगे वो तो एग्जीक्यूट होंगे, क्योंकि वो नॉर्मल रिटर्न था। तुम उस रिटर्न होने के बाद जो स्टैक्स में जो फंक्शन है उसका कुछ नहीं कर सकते।
एंड हम एक्सप्लिसिटली डेफर को कॉल कर सकते हैं, लाइक विदाउट अ पैनिक, नॉट नेचुरली।
मतलब समझो, सो बेसिकली डेफर क्या है, अगर तुम्हें कुछ लेट्स से कुछ क्लीन अप करना, तुमने एक पीस ऑफ कोड लिखा है, बट तुम्हें चाहिए कि जब भी ये फंक्शन एग्जीक्यूट होके खत्म हो जाए, दिस इज वन एग्जांपल, मुझे कुछ क्लीन करना है, लेट्स से तुमने डीबी कनेक्शन बनाया था और वो फंक्शन एग्जीक्यूट हो गया, तुमको कनेक्शन क्लोज करना है, तुम क्या कर सकते हो, स्टार्टिंग में ये एक डेफर लिख लो, उसमें क्लीन अप का कोड लिख, ताकि तुम्हें फिर बाद में कुछ करना नहीं है, जैसे ही फंक्शन एग्जीक्यूट हुआ, रिटर्न हो गया, वो डेफर कॉल करके कनेक्शन क्लोज कर लेते हैं। दिस आर सम केसेस जहाँ पे हम डेफर यूज कर रहे हैं एक्चुअली।
बट तो स्पेशल यूज केस है, जैसे आपने अभी बोला कि लाइक डीबी कनेक्शन क्लोज के लिए एंडिंग मना लिखते हुए हमने डेफर में डाल दिया ताकि ऑटोमेटिक बाद में कॉल हो जाए।
हाँ, तो अभी ये
नेक्स्ट वही देखने वाले कि स्पेसिफिक यूज क्या है। अभी डेफर में हमने देख लिया कि डेफर एग्जीक्यूट कब होता है।
हाँ।
अब किस केस में एग्जीक्यूट हमारा पैनिक, अब हमने देखा कि हमारा प्रोग्राम पैनिक हुआ था एक्सप्लिसिटली, तो उसने स्टैक ट्रेस प्रिंट किया था और डेफर रिटर्न किया था, तो वो ना करके हम उसको रिकवर कैसे करें, हम खुद से उसको वो खुद से एग्जिट ना हो, हम खुद उसको कैसे एग्जिट करवाए, तो उसके लिए हम डेफर, सो वी हैव panic and recover in Golang. So we also have, whenever our program panics, we have to recover it explicitly. So in Go, panic and recover are technically similar to exception handling, like in other languages, Java or Python. The panic is similar to exception, throw or raise an exception, and recover is similar to the catch exception. So, but in Golang, it is always encouraged to use error handling instead of this exception handling. But in some cases, we also required this panic and recover. So what happened when a panic is encountered? So we have seen that our Golang program has panic, but what has actually happened? So the program stops execution of function whereas panic has occurred. It explicitly stops the function, and program goes out of control. It does not know how to exit, so it exits abruptly. So after its panic, all the defer functions are executed from the stack. A function returns to the caller and function behaves like call to a panic. This process continues until the all functions are called and until all functions in the current Go routines have a return. Suppose I have multiple functions call, like function A calls function B calls function C internally, and panic happens in a function C. So this panic, the program ends abruptly at function C and returns the panic to the function B. So what the caller, when wherever the function C is called, it takes this as a panic, and this will go return until the main function. So program ends abruptly and all defer functions are returned. The panic reaches the main and terminates the program. So at the end of the panic, the stack trace will be the, we don't have a stack trace. So if want stack trace to include, there is a function std error. We can use that function to print the stack trace. So let's understand this by example. So are you okay with the pace of the training, or should we go slow or fast? Let me know. Okay.
चालू करो चालू करो मेजॉरिटी के वो इधर से तुम
अरे आपोआप बंद होतोय मे बी नोट चालू असते.
30 है 30 खाली वो चेंज नहीं हो
Okay, let's continue. So I have a function A. Guys, let's continue with the training. Yeah. So I have a main function. In the main function, first statement I am printing is hello world, and I am calling function A. So what is the responsibility of function A? Function A also prints the start of A. In the defer, it prints that end of A, and it calls function B. What function B does is it's a prints start of B. In the defer, it prints end of B, and it creates a panic. So can someone guess the output here? What will be the output?
Hello world. Then start of A, then create, then start of B,
Okay.
then panic, then end of B and end of A.
Okay, correct. So this will be the output. Everyone has understood, no?
yes yes
Okay. If you have any questions, please ask. No question is a silly question here.
So, I don't know if this works, but if we handle panic like exception handling, if I'll say this, you said that panic is kind of an exception, right? So, and when panic occurs, therefore is always called out, right?
Yeah.
So if we handle a panic,
We are not handling panic here.
no, we are not handling panic over here. But if we handle panic, so still the data will get returned all.
Yes.
So
Actually,
okay.
we are recovering the panic in defer itself. When a program panics, it doesn't know how to go further. Like
Yeah,
it ends abruptly.
Yeah.
So that's the use case when you use the defer. It prints it goes executes the defer statement, right? So in the defer itself, we recover the panic. So it will be executed anyhow.
Okay, understood.
In
So
the
I
further
think
examples, I'll show how to recover from a panic.
okay, so this is how we explicitly
Yeah.
clean the defer.
Here I am only showing in what cases the means panic happens and what happens when like function main is calling A is calling B. So this function, we have a tree of functions, right? So this was I want to show the example, like in this case how it panic means defer behaves. Okay, so we'll move forward. Yeah. So when does a panic occur? So panic can occur at runtime either because of some abnormal condition that we aren't prepared to handle gracefully, or we can create a panic with the use of inbuilt panic function, right? That we have seen both. So the common cause of panic is, suppose if we don't want to create a panic explicitly with the use of panic function, but how does the Go program itself panics? So these cases are, first one is nil pointer dereference. The second one is index out of range. Third one is divide by 0, and fourth one is assignment to nil map, and there are many more. So for the training purpose, we have chosen only these four. I'll show example in short. We are just running out of time. So yeah. So we are just declaring one type point here. This is a struct. we are declaring one method for this type point, and we are returning the square root of this x and y. X and y are the fields of type float. So in the main function, what I am doing is I am creating one variable of one object p of type point, and I'm just printing the absolute means the square root of this function. But what happens is this x and y do not have any values assigned to it, so it will refer to a nil. They have no pointer. It will refer to a nil, and our program will panic. Let's run this. So invalid memory address or nil pointer dereference. This is where our program has panicked, but we don't have any default statement here, so none of the statement is executed. The second one is index out of range. Yeah, so I have one array of size 3, and I'm trying to access the fourth element. So this will print if there is no error, it will return that normally return without panic, and if the program panics, it will abruptly return. It will never return, reach to line number 8. So index out of range with line 3, and line number 8 has never been printed. The third is divided by 0. I will skip this. That's the normal. And third is assignment to a nil map. So I have declared one map here at line number 6. Have you learned about map? What is a map data type in Golang?
Not
How
in
to declare
Golang,
map?
but in our other
Okay,
languages,
In general.
C++.
Okay. So this is the declaration. We declare map in Golang, where e of map int string, but this is an empty map, nil map. But whenever we are trying to assign any value to a nil map, it panics the program. What at line number 7, what I'm trying to do is I'm trying to assign a key 1 and value sample. I'm trying to assign a value, this value to a map, and if this value is assigned successfully, I'm printing that normally return without panic. If my program panics, it will panic and will return end it at line number 7 itself. So yeah, a panic assignment to entry in nil map. So this is how panic occurs. Yeah. So the thing is, how do we recover from this panic? We don't want our program to end abruptly. So in Golang, we have recover keyword. In this recover keyword, we can recover from panic. So recover attempts to recover from a panic, and recover must be attempted in a defer statement as normal execution flow has been halted. So we never know where panic can occur. So we always attempt to recover a panic in a defer statement. So let's consider one example. Go playground. Yeah. So I have a main function here which prints hello and some letter. I'm calling a function foo, and at the end of the function, I'm returning panicked and recovered. So what does the function foo does? So at the first, it just have a normal print statement, start of the foo, and at line number 16, I have used the recover keyword. See, I use the recover keyword in a defer function. So this is an anonymous function. This is how we declare an anonymous function. I have declared a function without any name, and I have called immediately after the function ends. This is the function call, function declaration along with its call. So what I have done inside the defer function is that if I have assigned I have called the recover function and assigned that value to the R, and I am checking if R not equal to nil. If R is not equal to nil, this means that there is some panic in my program. So I'm just printing that panic occurred, and I'm printing that value here. So after this defer is not executed immediately. This is only evaluated, and the program goes at panic. I am panicking. So this is an explicit panic, and at line number 22, it's end of the foo. So our program explicitly panics at line number 21. But what happens is after the panicking, defer statement gets executed. So what it checks that value of recover. So the program has already panicked. So our R will be not nil. So it will go into R not equal to nil. It will simply print that panic has occurred, and it will print the value in this format specifier %v. What %v capture is whatever the value our panic has written. This will be stored in this R. This recover returns that value, panic value. So can anyone guess what this program will output?
First arrow statement.
Okay.
Then
Start of
foo function.
Hmm.
Then start of foo.
Okay.
Then I am panicking.
Okay.
And then panic occurred. And the
Huh? Then
Then I think that
Return to
print
end of
statement, end of like,
Panic and
panicked
recover.
and recovered
okay,
instead
so
of
let's see here. Our
end of
program has not ended abruptly. We had a panic, explicit panic, but we have recovered from that panic. Like so, first it will print hello, then start of foo, then it goes here, but I am panicking. But this panic is recovered immediately in a defer statement. This print panic occurred, and this placeholder has a value of a panic, like I am panicking. Then it returns to the main function, like it does not end abruptly. It returned to the main caller function and it prints that panicked and recovered. I hope I am totally recovered from the panic. So, but do you have observed anything different in this?
end of
Uh, also, this and in this output, are we missing something?
Yes, sir.
No, not end of.
Panic occurred as printed in same
Not the panic message.
Yeah, we didn't have the stack trace here, like where the panic had happened, what was the actual reason of the panic. So for this we have a std error. Using that error, debug.std error, we can print whole panic trace before recovering from panic.
So is it good to use a defer? Like if you're working on a big project,
Yeah,
so one
we are mostly using defer keyword.
no that panic one, recover one.
That's the standard practice we do in.
So did you get the main logic behind using recover in defer? Why did we do that? Because if you see in that example, whenever panic occurs, it just skips rest of the lines. So अगर ये recursively भी functions call हुए, तो अगर मैंने ये function किधर और से call किया था, जैसे ये panic हुआ, ये function call जिधर से भी हुआ था, उस वो function में भी जो next lines थे वो कुछ execute नहीं होने वाले. तो अगर उसके नीचे लिखा है कुछ recover वगैरह, तो it will never be called. So इसलिए it's recommended. अब तुम फर्स्ट स्टार्ट में भी अगर आई एम श्योर तुमको मालूम ही है कि पैनिक किधर आने वाला है, तो फिर मैं किधर जाके लिख सकता हूँ, बट वी कांट डिफाइन किधर से पैनिक आएगा. सो इसलिए हम डेफर और प्रेफरेबली, अगर ये डेफर मैंने नीचे भी लिखा होता तो फिर वो कभी डेफर में जाता ही नहीं, तो वी प्रेफर कि डेफर स्टार्ट में ही लिख दो फंक्शन के, बिकॉज वैसे भी वो एग्जीक्यूट नहीं हो रहा है. इट विल बी एग्जीक्यूटेड व्हेन द फंक्शन कॉल रिटर्न्स, किसी भी रीजन से. सो इट मेक सेंस टू एक्चुअली लॉजिकली अगर सोचो तो कि रिकवर डेफर में क्यों लिखा, क्योंकि वी डोंट नो कि कभी पैनिक आए. जैसे ही पैनिक आएगा, जैसे ही वो स्टैक ट्रेस रिकर्सिवली पीछे जाएगा, जो भी नीचे के लाइंस थे वो कुछ एग्जीक्यूट नहीं होने वाला, बट डेफर विल ऑलवेज एग्जीक्यूट. तो इसलिए इट लॉजिकली मेक सेंस कि रिकवर को डेफर में डालो.
Sir, could you go back to the playground?
Okay. Positioning of paper always matters.
Okay. This function में panic call हो रहा है. Recover के बाद he'll omit all the lines. But लेकिन अगर main में call हो रहा है तो recover होने के बाद execute normally होगा.
फंक्शन पैनिक हुआ है ना, उसने कॉलर को वापस कंट्रोल दे दिया, कॉलर को कंट्रोल दे दिया ना, वहाँ पे कंट्रोल नहीं है इस फंक्शन के पास, कंट्रोल कॉलर के पास चला गया, तो एग्जीक्यूशन वहां से फिर से सीक्वेंशियल स्टार्ट होगा.
इधर से कॉल हुआ था, राइट?
हाँ सर, वो
ये पैनिक हुआ, ये लाइन एग्जीक्यूट,
हाँ.
क्योंकि ये जैसे ही रिटर्न हुआ, पहले वो इधर नहीं गया, पहले उसने ये एग्जीक्यूट किया डेफर, राइट? अब उसने यहाँ पे वी रिकवर्ड फ्रॉम द पैनिक. अब जैसे ही ये फंक्शन कुछ रिटर्न नहीं कर रहा है एक्सप्लिसिटली, बस हमने प्रिंट किया, बट व्हाट दिस रिकवर डज इज वो पैनिक को रोक रहा है कि वो प्रोपोगेट नहीं कर रहा है, टू बैक प्रोपोगेट नहीं कर रहा है जैसे वो कॉल होगा. अब जब यहाँ पे आएगा, अब ये फंक्शन में पैनिक नहीं है क्योंकि रिकवर्ड हो गया फ्रॉम द पैनिक. अब वी कैन कंटिन्यू द एग्जीक्यूशन एज इट वाज.
Can you once remove the panic statement that I am panicking and then show the output?
So what are your guess? What will it output?
Defer
I think
statement only
it
होगा.
will execute or not.
It will be not executed as R is not R is equal to nil.
So it will not execute.
So it will normal execution say. नॉर्मल, ये हमने एक्सप्लिसिटली पैनिक एंड रिकॉर्ड लिखा है इसलिए वो आ रहा है, मतलब वो कंपाइलर का नहीं. हाँ ऊपर का एक्सप्लिसिटली लिखा है, हार्ड कोडेड वैल्यू. सो जैसे कि मैं आई एम पैनिकिंग यहाँ पे पास कर रहा हूँ, अगर मैंने यहाँ पे नील पास कर दिया तो क्या होता है? हम्म? कौन सा मैसेज? लाइन नंबर 18 और ओके ओके
Panic called with नील
नील
argument.
आर्गुमेंट पैनिक हुआ था, बट उसने नील आर्गुमेंट पास किया, बट उसने कंडीशन ही चेक नहीं, उसको यहाँ पे नील मिला, तो विद नेवर पास नील टू द पैनिक. So this is the one. So what record does is record will return the argument provided in the shell panic if the program is currently panicking. That's similar we have seen an example. If the program is not currently panicking, record will return nil value. So and do not send nil as a param to a panic function call. Otherwise, recover will take up the nil value and will silently exit. Our program is panicking, but it will silently exit and it will never recover. So if we recover from a panic, we lose the stack trace about the panic. This is also we have seen, and we will use the debug.print stack statement to get the stack trace of the after the recovery. So this is the example for this. Just we are adding one line debug.print stack here. This will recover from a panic along with the stack trace. This is the same example, just difference of this one line.
So should
So,
we use standard error or print stack?
So this print the error stack, like panic stack. So we are using online compiler, so that's why this is doing go fake time source. But when you are using our normal VS Code, this will print a proper function or file path where the panic has occurred. So the next one is so does anyone have any doubt? Yeah. Okay.
If we like use three different,
Hmm.
but in that we do a database call. So as you said, it will get evaluated but not get executed.
Hmm.
So if we are updating a same value in all these three calls,
Okay.
then which value will get updated?
So that's what we done in one similar example. We were updating the value of I, right? So first I was 1, we were putting that value in a defer statement. So it got evaluated. Value of I got evaluated itself, but it was not executed. So I incremented that value I plus plus. Again, I have printed that value in defer statement. So again, this value of I was incremented means overwritten to 2. But then again, it was evaluated to 2, but it was not executed. And then I squared that value I into I. So that value of I becomes, that is the same example you are talking about, right? Maybe that value came from database or it's a normal variable, right?
Are you talking about a query? Let's say you have written something to update a value in database, right? So by evaluate, he means in that example, said example where we consider I. So what it does is it stores the value of I in stack. Like what was the value of I at that time when we put the defer function into the stack. It is not being executed yet. Just storing all the related data it wants when the function will execute. So in your case, what will happen is it will just store whatever the query is, not yet executed. And then we go on stacking the defer calls, then it will execute one by one and the last defer call. So basically the last means the first which went in, that will be executed and that is the set for the database.
Query will be stored or the value of the query will be stored.
But depends कि तुम क्या कर रहे हो. जैसे for example query में तुम लोग ने कुछ variables डाले, right? So जो variables का अभी वो भी रहा, that also depends on a lot of factors. अगर सिर्फ वैल्यू है, नॉर्मल पास बाय वैल्यू है, तो फिर जो भी वैल्यू था उसको कॉपी बना के इट विल स्टोर. समझो ऐसा मेटा डेटा के सब तो वैसे नहीं रहता, बट वैसे समझो कि वो फंक्शन को जो जो वेरिएबल्स चाहिए थे जो तुमने पास किए थे उनकी वैल्यू वो स्टोर कर रहा है. बट अगर इफ यू हैव यूज्ड पॉइंटर्स, क्योंकि उसे स्टोर तो कर लिया उस टाइम पे जो वैल्यू था, बट आगे जाके किसी और रेफर कॉल में या किसी फंक्शन में भी इफ यू चेंज दैट पॉइंटर का वैल्यू, देन क्योंकि वो इंटरनली पॉइंट तो कर रहा है उसी एड्रेस को, सो वो वैल्यू चेंज हो रहा है. बट इन दिस केस सिंस वी यूज अ नॉर्मल वेरिएबल, वो पास बाय वैल्यू हुआ तो इवेल्युएटेड मतलब वो बस उससे वैल्यू स्टोर करके रखे. जो एक्चुअली जब उसने fmt डॉट प्रिंट एग्जीक्यूट किया तो जो भी वैल्यू स्टोर था इट रेफर टू दैट.
What this mean? I also know like if you do an API call, like you update in the database itself. Will it update first or update the data when it gets executed?
But एक तो we will not call this a defer, but even if we do तो क्या होगा क्योंकि जो लास्ट गया था स्टैक में then that defer function will call the database किया उसने अपडेट उस टाइम पे, but now still we can still update right the same data. So अब वो inconsistent होगा वो execute no doubt, बट अभी डिपेंड्स तुमने वैल्यू कैसे पास किया था. अगर जो भी तुम्हें वैल्यू अपडेट करना था वो तुमने एज अ पॉइंटर पास किया होगा और किधर बीच में चेंज किया तो और जितने भी डेफर स्टैक्स थे जिनमें वो वेरिएबल यूज हुआ है वो पॉइंटर वेरिएबल तो उनमें सेम वैल्यू रिफ्लेक्ट करेगा. बट अगर वो पास बाय वैल्यू था नॉर्मल वैल्यू बस वो कॉपी वर्क रहा है वो 1 2 ऐसे रख रहा है फॉर एग्जाम्पल अगर इंटीजर है तो वो वेरिएबल को अभी रेफर नहीं कर रहा है वो बस वैल्यू स्टोर किया उसने. अब जो भी वैल्यू उस टाइम पे उसको मिलेगा जो उसने स्टोर किया था it will update that in the DB.
So can we do silent?
Sorry.
नहीं
Silent रिकॉर्ड नहीं करते.
नहीं साइलेंट रिकर उल्टा है मतलब वो जो मतलब साइलेंट रिकर वाला वो नोटिस ही नहीं हुआ.
नहीं मतलब अगर पैनिक अगर हुआ हमने उसे रिकवर किया लेकिन रिकवर साइलेंटली कर सकता है ऐसा होता है लाइक कोई मैसेज प्रिंट नहीं करेगा नॉर्मली.
मैसेज मतलब वो तो एग्जांपल था उसके अंदर तुम और कुछ लिखते हो कि जैसे इधर तो स्टेटमेंट बस लिखते हैं ना एक प्रिंट स्टेटमेंट बट तुम्हें और कुछ और करना हो कि अगर तुम्हें नोन कॉसेस बताओ कि इस रीजन से हो सकता है पैनिक तो तुम फिर वो चेक करोगे उसमें एक मेथड तुम चेक करोगे कि पैनिक क्यों है और तुम्हें सॉल्यूशन मालूम है तो ठीक है वो स्टेप्स लिखो उसके अंदर. इफ नॉट दैट जस्ट लॉग वगैरह डालो या फॉर एग्जांपल इफ यू हैव हर्ड कि जब भी ऐसा कुछ एरर आता है हम नॉर्मली नोटिफाई करते हैं अगर तुम कुछ क्लाउड बेस्ड सर्विस यूज कर रहे हो लेट्स से कुछ क्लाउड वॉच ग्राफाना वगैरह कि उधर नोटिफाई हो कि कुछ इंपॉर्टेंट हुआ है तो उधर से वो चीज सॉल्व कर सकते हो फॉर एग्जाम्पल ताकि फिर आके कोई एक्चुअल डेवलपर देखे कि क्या इशू था
बट अगर आई वांट की पर्पसफुली रिकवर साइलेंटली हो जाए लाइक पैनिक कर हो ना लेकिन किसी को पता भी ना चला अगर वैसा कर सकते हैं.
आई एम नॉट गेटिंग पता ना चला मतलब तुम्हें बस लॉग नहीं डालना
लॉग नहीं डालना कुछ नहीं पैनिक हो गया.
चले वो एम्प्टी भी ले
Recover
सकते हैं
हो
ऐसा
गया.
कुछ प्रॉब्लम नहीं है बस तुमको वो रिकवर कीवर्ड यूज करना है to
हाँ
recover.
रिकवर कीवर्ड.
So clear enough with that. So the next part is context. So what context is? Package context is a standard library that provides the type context. So this context is included in the Golang standard library. So context is used when you want to pass around the context in our application. Like means this context carries the deadlines, cancellation signals, and other request scope values across the API boundaries and between the processes. Suppose I have one API call which takes around, let's consider 30 seconds to return a value from a server. So whenever a client requests this API to the server start immediately processing that request. But within like first 10 seconds, the client close this request, cancel this request. So how do we know how our program or server will know that this request has cancelled? So this is the part. This is the primary use case of a context. This context can cause whenever the deadline occurs. This can stop whatever it was doing. It returns to the caller. If there is a timeout, it also returns to the caller. And if you want to pass any values like request ID, session ID to the context, I can also pass this value with the help of the context. So incoming request to the server creates a context, and all outgoing calls to the server accept that context. So a context may be cancelled to indicate that work done on its behalf should be stopped immediately, and a context with a deadline is cancelled after the deadline passes. And when a context is cancelled, all contexts that are derived from that parent context all are cancelled. So let's see. These are the mainly two tasks that are handled by a context. The first one is cancellation and propagation, and the second one is the request scope values. So we can create context. How to create a context? Right? We can create a context using two functions from a package. We have a standard context package in a standard Go library. So the first one is context.todo and the second one is context.background. These both functions return the context, but there are use cases when to use the context.todo and a context.background. So when we are using the context.todo, this to do returns a non-nil empty context, and cold should use this context when we are unclear when what context we have to use, or context is not yet available. So at that cases we are using that context.todo, and the second context is context.background. So this is very similar to the context.todo, but this also returns a non-empty, non-nil empty context, but it is never cancelled and has no values and no deadlines. So it is typically used by the main function or the function initialization and in test cases. So this is the top level context for incoming request. So we can derive many context from this main context. So this is the primary differences between context.todo and context.background. So there are mainly four functions that are associated with the context. The first one is context with value. With this function, we can assign value to the context, like we can set any values in the context. The second one is context.with cancel. So we can this function returns the context as well as the cancel function. So if the context is cancelled, this function will return the cancel. This internally uses the channels. We'll teach the channels in upcoming session so that you can will understand that better. The third one is the context with deadline. So we can pass a deadline to the context that I want this context to be executed, means this request to be executed within a certain period of time. If not, cancel that request. We can do this with the help of context with deadline and context with timeout. We can also add the time similar to deadline. We can also add timeout in the context. You can read more about this. I have provided links over there. I'll share the PPT with you guys so you can refer to it. These are links to the standard documentation. So, what is context? Context is immutable. So, once the context is created, I cannot modify that context. But I can derive multiple context from that context. So, this will the parent context. I can derive a child context and add more value to that context. So, in this way, I cannot change the value of main context, but can add the multiple information by using the child context. So, to create a new context, you wrap existing context and add more data, and you can wrap context multiple times, so you can think it's a tree of values. So this is how the context works. Now let's take one example. So basically this is a I am creating one context. Internally I am passing multiple context to it. Let's take the base example, root level context.background. This is the root context. I am passing to the context.value. So I have taken context at the background at the top level. So, and I am passing a session ID here. In this context, I am passing a session ID. So this context.with value returns a context with session ID. So this context is passed to the context with deadline function. So this deadline function has now session ID along with the request deadline. And this context is again passed to the context with value. Sorry, this is the context is created, and this context is again passed to the trace ctx. So this is the trace of the index. So whenever I use the log ctx and pass this context to the log ctx, I can zipkin trace and request logger. Means I can access all these values with the help of that context. So this context have all these values.
So basically, if you want to wrap multiple values in a context, so as you said, that context is immutable. If at one time I assigned a value, let's say a key value pair in a context, but now I want to add more details to it. So what we can do is we can just go on wrapping the context. So by wrapping, I mean we are creating a new context, let's say with context dot with value. So first argument is the parent context. क्योंकि मेरे को वो वैल्यू भी चाहिए था जो उसमें I'll pass the parent context plus जो new values मेरे को आएगा. So that way. And similarly, I can go on adding like this. अब मेरा जो दूसरा context create हुआ उसमें new value भी है plus parent context का value भी है. So if you see वो जो request ID है जो last वाला था उसमें क्या है request ID भी है, वो जो request deadline वाला था वो context का भी values है, session ID भी है, और जो main context था वो भी है. तो मतलब वो चाइल्ड कॉन्टेक्स्ट में वो पेरेंट्स जो है उसके हायरार्की वो सब वैल्यूज. एंड नाउ मेन थिंग इज बेसिकली अब तुम कॉन्टेक्स्ट किसको भी पास कर सकते हो, और जब भी कॉन्टेक्स्ट कैंसिल होता है, लेट्स से ड्यू टू एनी रीजन, तुमने उसको डेडलाइन या टाइम आउट लगाया है तो कुछ मैंने टाइम आउट दिया था 10 सेकेंड्स। तो मैंने मेन फंक्शन से कॉन्टेक्स्ट चालू किया था विद अ टाइमलाइन ऑफ टाइम आउट ऑफ 10 सेकेंड्स, और मैं इंटरनली चाइल्ड फंक्शंस को पास करते गया वो कॉन्टेक्स्ट। अब जैसे 10 सेकेंड्स हिट होगा, लेट्स से रिकर्सिवली वो फोर्थ फंक्शन में था, अब जैसे ही मेन कॉन्टेक्स्ट कैंसिल हो गया, व्हाट हैपेंस इज इट द सेड कॉन्टेक्स्ट अभी जो फोर्थ फंक्शन में है, इट रिटर्न्स एन एरर कि कॉन्टेक्स्ट कैंसिल। अब देर आर वेज टू हैंडल इट, अब तुमको वो एरर हैंडल करना है कि नहीं करना है वो तुम पे है। बट इफ यू हैंडल द एरर तो इफ यू यूज होगा बेसिकली, लेट्स से एचटीटीपी रिक्वेस्ट है, अब एचटीटीपी रिक्वेस्ट है, अब तुम बहुत टाइम तो नहीं रुक सकते, तो जनरली हम क्या करते हैं, हम एक टाइम आउट दे देते हैं। बट अभी हमें नहीं मालूम ना वो रिक्वेस्ट कौन से फंक्शन में ट्रैवल कर रहा है और क्या क्या रिसोर्सेज यूज कर रहा है। तो हमने वो रिक्वेस्ट में कॉन्टेक्स्ट सेट कर दिया कि लेट्स से 20 सेकेंड्स, अब जाओ जो भी करना है करो। जैसे 20 सेकेंड्स हो जाएंगे, विल लिसन टू एरर्स फ्रॉम दिस कॉन्टेक्स्ट, एंड वेन एवर इट एरर्स आउट, तो कुछ स्पेसिफिक एरर्स होते हैं कि कॉन्टेक्ट मतलब एक एरर इज कि कॉन्टेक्स्ट कैंसिल ड्यू टू टाइम आउट, तो ऐसे एरर्स होते हैं। तो तू बेसिकली लिसन कर दो कि यही एरर था ये स्पेसिफिक, अब ये अगर स्पेसिफिक एरर है तो यू नो कि अभी रिटर्न करना है, तो यू रिटर्न, और कुछ यूजर फ्रेंडली मैसेज रख सकते हो कि यूजर रिक्वेस्ट टाइम आउट या जो भी तुमको चाहिए। अब जैसे ये कॉन्टेक्स्ट पीछे पीछे जाएगा, तो इससे बेसिकली जो रिसोर्सेज एक्वायर किए थे तुम लोग के एचटीटीपी रिक्वेस्ट ने, वो भी क्लियर होते जाएंगे, तो रिसोर्सेज भी ज्यादा टाइम तक होल्ड नहीं होते। अगर मैं नहीं देता टाइम आउट तो क्या होता, जब तक जितना भी टाइम उसको लग रहा है, जब तक वो नेचुरली टाइम आउट नहीं होता तब तक वो प्रोसेस करते रहता। दिस इज वन ऑफ द रीजन। और ये आगे तुम्हें कुछ वैल्यूज पास करने आगे वाले फंक्शंस में, और यू आर नॉट श्योर कि किधर क्या पे मुझे लग सकती है वैल्यू, यू कैन बेसिकली यूज कॉन्टेक्स्ट फॉर दिस स्मॉल स्टफ। कुछ छोटे मोटे वैल्यूज है, सिंगल स्ट्रिंग है, इंटीजर है, यू कैन एक्चुअली तुम यूजर डिफाइंड टाइप्स भी उसमें दे सकते हो, अगर तुम्हें स्ट्रक्ट वगैरह भी दे रहे हैं तो वो भी तुम दे सकते हो, उसमें कुछ रिस्ट्रिक्शन नहीं।
Okay. So the next topic is dependency management. So are you guys aware about what dependency management
बस
means?
एक ही चीज था वो कॉन्टेक्स्ट में, तुमने स्टार्टिंग में देखा ना टू डू और बैकग्राउंड, उसका जब भी टाइम मिले बस खुद से इंटरनली डिफरेंस देखना कि कुछ है क्या उसमें, टू डू और बैकग्राउंड के इम्प्लीमेंटेशन।
Okay. So what do you mean by dependency management? Anyone? So what do you mean by dependency?
The external packages we are using for managing them,
Okay.
managing their version is somewhere.
Yeah, so rightly as mentioned by him. So dependency management, we are using various external packages in our Golang. So there are not every packages that are available in a Golang standard library. So we also required some external packages, some open source repositories. So we have to maintain that packages along with their versions. So what project use what version of which packages. So we are using that in a dependency management. So this is known as the dependency management. So is dependency management essential? Like, what do you guys think? Dependency management is essential or not? Yes. So because if I'm working on some project and I want my new developer is onboarded on that project, he should build that project easily. He should download that dependency easily using that single file. That he don't have to worry about the what dependencies are required. Using some command, he can do that easily. So does anyone know that if Go provides that tool, any tool for this dependency management? So in Golang, we have Go modules. So using Go modules, entirely we are doing the dependency management. So Go module is a new dependency management. So Go modules is a new dependency management system inbuilt in Go that Go that makes dependency version information explicit and easier to manage. So currently, do you know what version you have installed of Go? 1.25. Yeah, that's the latest version, right? So from Go 1.11 and Go 1.12, this include the preliminary support for Go modules, and starting from Go 1.13, Go module is the default for all development. So there are some commands that we can initialize the module in it. So whenever we declare any project and we require the third-party dependencies, there is a command that go mod init, and we can provide the name of the module in front of init. So this creates a new module initializing the go.mod file that describes it. Means whenever we run go mod init in that specific folder structure folder directory, we create a new file go mod init. And then what is the inclusion of this go mod file? This go mod files include the name of that module, what you have provided in it. This includes the Golang version you are using. This provides the dependencies, direct dependencies as well as the indirect dependencies you are using. Direct dependencies are the dependencies you are directly imported in your code, and indirect dependencies are the dependencies that your direct dependencies are using. So all these dependencies are included in this go.mod file. So whenever if you want to build any Go program, you just write go build. Whenever your main function is there in the directory, you just type go build. It will build an executable file of your Go program. And whenever you want to test anything, if you have written a test file, go test is the go test hyphen will run all your test files. So go list hyphen m all. This lists the current modules all dependencies. Go get is the suppose I'm doing the third party dependency. I need that dependency first to install in my system. So whenever I provide go get, and suppose I provide one link github.com and some link of the module or third party packages. So this will download the dependency in my system. So this is the go get. And go mod tidy, whenever suppose it is not the case that whenever I install one dependency in my system, I will require that dependency for the whole lifetime of the project. Like there is some system upgrade, or I want to change the packages from one packages to another packages. So I don't edit that go mod file manually. So it's not recommend to edit that file. So what my go mod tidy does is it cleans up, it checks what dependencies are required, what are the new dependencies added, and what dependencies that are no more required. So it updates that, it removes the unused dependencies from that go.mod file. So have you understood what go mod file is used for? What are the contents of go mod file, and what is the use case of the go modules? There is also one file along with the go mod. We also have you ever seen go.sum file?
Yes.
Yeah. So that sum file also include the checksums of the hashes that are included in go mod. So if you want to read more, you can read more about what the go sum file includes. What are the hashes included in go.sum file?
If you have ever worked with Node or stuff, you've heard of package.json and package log.json. Same concept. Go.mod refers to package.json and go.sum package
Log this.
Okay, so this was still in this session. So anyone has any doubt until this?
overwhelming हो रहा है.
कुछ सर के ऊपर से गया क्या कुछ टॉपिक वगैरह ऐसे?
इम्प्लीमेंट करना पड़ेगा.
हाँ, यस.
Context वाला topic.
अच्छा, मतलब अभी तो इनिशियल इतने बच्चे पढ़ोगे, कुछ क्वेश्चंस होगा तो मतलब हम लोग इधर ही है, आप कभी भी आ सकते हो. इतना सारा एक सेशन में कवर करना मुश्किल है, क्योंकि बहुत सारे मतलब एरियाज कवर हो चुके जब से सेशन स्टार्ट हुआ है. मतलब स्टार्टिंग से एंड तक हम जब तक
इसको ऐसा सोचो कि ऐसा कुछ जब तुम एक्चुअली कुछ इम्प्लीमेंट करने जाओगे ना या खुद से देखोगे तो एक रिकॉल होगा कि कुछ तो हाँ कुछ तो सुना है या
इसके
कुछ
रिलेटेड
तो याद-
सेशन में हुआ था, तो उसके रिलेटेड आपको थोड़ा और पढ़ने मिलेगा. कुछ डाउट्स आएंगे, पूछो, बहुत सारे डाउट्स आएंगे, पूछा करो.
कॉन्टेक्स्ट का बस सिंपल सोचो कि मेरे को डेटा पास करना है आगे फंक्शंस में, और उसमें कुछ टाइप्स है. अगर मेरे को ठीक है, वन इज कि मैं डेटा पास कर सकता हूँ, और दूसरा इज कि अगर मेरे को मेरा कोड एग्जीक्यूशन रोकना है तो उससे मैं डेडलाइन या टाइम आउट देके रोक सकता हूँ. मेन दो यूजेस यही है. आप जब भी कोड करोगे तो देखोगे कि एक तो मेरे को वैल्यू पास करना है, कुछ अब जो ऑथेंटिकेशन हेडर वगैरह आया सामने से, तो मेरे को आगे के फंक्शन पे पास करना है. तो मैं एक बार कॉन्टेक्स्ट में डाल लूँ जिस फंक्शन को भी चाहिए. जैसे फॉर एग्जाम्पल अगर मेरे को नॉर्मली कुछ वैल्यू पास करना है किसी फंक्शन को, मेरे को आर्ग्यूमेंट देना पड़ता है, राइट. अब आई डोंट नो कि किधर किधर लगेगा, तो सब जगह तो मैं आर्ग्यूमेंट नहीं दूंगा, तो मैं कॉन्टेक्स्ट में डाल दूंगा वैल्यू. अब क्योंकि कॉन्टेक्स्ट तो नॉर्मली अगर अब देखोगे ना तो हम कॉन्टेक्स्ट हर एक फंक्शन को पास करते ही. तो क्योंकि अगर मेरे को कभी भी कैंसिल करना पड़ा फंक्शन वगैरह तो आई कैन लिसन टू द एरर फ्रॉम द कॉन्टेक्स्ट. या तो ये केस कि जब मेरे को कुछ वैल्यू चाहिए कॉन्टेक्स्ट से, तो ऐसी सब चीजें जो आई डोंट नो कि मेरे को लगेगी कि नहीं लगेगी, तो कुछ बेसिक चीजें जैसे ऑथराइजेशन हेडर मैं कॉन्टेक्स्ट में देके फंक्शंस में पास कर सकता हूँ. तो ये एक्सप्लिसिटली आर्ग्यूमेंट देने की जरूरत नहीं है फंक्शन की, क्योंकि मेरे को मालूम ही नहीं कि इसको लगेगा. वन ऑफ द रीजंस.
सपोज एक रिक्वेस्ट है, अब हम तो स्मॉल स्केल पे प्रोग्राम बनाते हैं, बट प्रोडक्शन लेवल पे कोड बहुत बड़ा होता है, उस पे रिक्वेस्ट पे मल्टीपल्स आते हैं। अगर मुझे एक रिक्वेस्ट ट्रेस करनी है कि सपोज डिलीट रिक्वेस्ट कॉल हुई है, पोस्ट रिक्वेस्ट कॉल हुई है, तो ये ट्रेस करनी है मुझे। तो जब भी एपीआई एंड पॉइंट कॉल होता है, मैं क्या करता हूँ, स्टार्टिंग में एक रिक्वेस्ट आईडी असाइन करता हूँ उस रिक्वेस्ट को, और वो रिक्वेस्ट आईडी विथ वैल्यू से सेट करता हूँ कॉन्टेक्स्ट में। तो जहां जहां वो मतलब हैंडलर लेवल से डेटाबेस लेवल तक जहां जहां वो रिक्वेस्ट प्रोपोगेट होती है, वो रिक्वेस्ट आईडी वहां तक प्रोपोगेट होगा। अगर मुझे कुछ इन्फो लॉग्स भी डालने हैं या कुछ एरर लॉग्स भी डालने हैं, तो मैं ट्रेस करना मुझे आसान रहता है कि वो उस रिक्वेस्ट आईडी के लिए क्या क्या लॉग्स थे, तो मुझे उसी का फ्लो दिखेगा सिर्फ। तो ये भी वन ऑफ द यूज केस है कि कंटेक्स्ट यूज इसी तरह भी कर सकते हैं।
Like you said, context can be nested. So let's say we have 10 context, and in the first we have set a timeout, and the context has reached to 7 coverage. So when the timeout will be occurred, executed, then as you said, the contexts are like immutable. So what will happen for the 5, 6, 7? So like timeout has occurred in the fourth context.
तो कंटेक्स्ट एक दूसरे चैनल से मतलब कम्युनिकेट करते हैं, तो पीछे प्रोपोगेट कर देते हैं मेन कंटेक्स्ट तक कि वो कैंसिल हो चुका है।
अच्छा, मतलब 5, 6 और 7 क्लियर हो जाएंगे। मतलब
उसके बाद के
चाइल्ड में वो प्रोपोगेट होगा, क्योंकि पहले वाले को तो मालूम ही नहीं है ना।
अच्छा, वो चाइल्ड डिलीट हो जाएंगे फिर, क्योंकि फोर्थ में तो ये
तो
होगा
मतलब ऐसे ही हो रहा है ना कि ये फर्स्ट था, सेकंड, थर्ड, फोर्थ।
Yes.
अब जो फिफ्थ, सिक्स, सेवंथ आ रहे हैं वो इससे इनहेरिट करते जा रहे हैं। अब अगर फोर्थ बोल रहे हो कि क्या कॉन्टेक्स्ट कैंसिल हुआ,
मतलब आप वहाँ पे हमने टाइम आउट सेट किया था लाइक अगले कंटेक्स्ट के लिए, तो हम लोग एग्जीक्यूट करते करते 6, 7 पे पहुंच गए, तो लाइक फिफ्थ और सिक्स्थ एग्जीक्यूट हुआ ना।
कंटेक्स्ट बोल रहे हो कि कुछ फंक्शन कॉल बोल रहे हो?
लाइक कंटेक्स्ट में
कंटेक्स्ट एग्जीक्यूटिव हो सकते हो। क्या होता है, हम
Execute-
क्या कर रहे हैं, बस जैसे वेरिएबल डिक्लेयर करते हैं ना, वैसे कंटेक्स्ट डिक्लेयर कर रहे हैं। एक वेरिएबल ही समझो उसको, बट ऐसा जैसे फॉर एग्जांपल स्ट्रिंग इम्यूटेबल है ऐसा समझो। तो हम क्या कर सकते हैं, अब उस स्ट्रिंग में तो वैल्यू ऐड नहीं कर सकते, हम एक नया स्ट्रिंग बना सकते हैं जिसमें वो स्ट्रिंग प्लस जो भी नया ऐड करना था उसके आगे वो डेटा ऐड कर। वैसे ये कॉन्टेक्स्ट भी, तो मैंने कॉन्टेक्स्ट क्या किया, ओरिजिनल कॉन्टेक्स्ट लिया और जो भी नया वैल्यू ऐड करना था वो किया और एक नए कॉन्टेक्स्ट में स्टोर करते गए। अब फॉर एग्जांपल एक फोर्थ कॉन्टेक्स्ट था, तो मुझे उसमें टाइम आउट चाहिए था, तो मैंने वो कॉन्टेक्स्ट बनाया, उसमें टाइम आउट डाला, लेट्स से 10 सेकेंड्स। वो कॉन्टेक्स्ट प्लस जो पहले की इन्फो थे, समझो पहले मेरे पास 3 स्ट्रिंग्स थे, वो लेके मैंने जो अभी नया कॉन्टेक्स्ट बनाया वो चारों मिलके एक नए कॉन्टेक्स्ट में डाल दिया। अब क्या होगा, जैसे ही अब ये कॉन्टेक्स्ट आगे आगे प्रोपोगेट करते जा रहा है दूसरे कॉन्टेक्स्ट में। अब ये कॉन्टेक्स्ट इधर भी है, जिस भी मोमेंट पे समझो फोर्थ कॉन्टेक्स्ट में आपने डेडलाइन सेट किया था और ऐसे तुमने जैसे 8 कॉन्टेक्स्ट बना दिए। अब जो 8 कॉन्टेक्स्ट है उसमें सब कुछ है, राइट, उसमें सब कुछ है। अब जब भी ये कॉन्टेक्स्ट कॉल होगा जिस भी फंक्शन में, अब इसके बाद सब इन्फो है, तो तब तक वो जो कैंसिल वाला कॉल था जिसमें वो एरर आएगा कि कॉन्टेक्स्ट कैंसिल ड्यू टू टाइम आउट, वो जिस जिस मतलब फिफ्थ, सिक्स, सेवेंथ, एट, अब इनके पास वो इन्फो है ना कि फोर्थ ने डेडलाइन लगाया है, तो उन सबके पास ये इन्फो रहेगा, मतलब उसके आगे वाले जो कॉन्टेक्स्ट है उनको नहीं मालूम ये चीज।
मतलब ये जो कंसेप्ट होता है, अगर रूट कैंसिल हो गया तो आगे की सब चाइल्ड कैंसिल हो जाती है।
हाँ वो तो, बट ये तो रूट कैंसिल हुआ था ना,
हाँ,
इसके आगे के चाइल्ड्स, तो ये जो फोर्थ के नीचे थे वो उसके चाइल्ड्स, राइट, ये जो ऊपर थे वो पेरेंट है। सो अगर पेरेंट कॉन्टेक्स्ट इज कैंसिलिंग तो ऑफ कोर्स चाइल्ड विल गेट कॉन्टेक्स्ट, बट नॉट वाइस वर्सा।